temporarily let me hide this so that it will not come in the way. You have seen here, I have got one object here, I have got one more object here. So, I will try to create a surface using this as the edge curves. I have an edge curve here, I have a reasonably okay thing, okay, small bomb is here, kindly yeah, just about made it. See this, I will just give it a so, because the surface is common with the other object, I have a reasonably well made one object I have here. Now, if you say because of this orientation this object can be built easily without any other thing, and meanwhile I will unhide the other object which I have kept there, the same see. There is a small error, I will try to correct the error. Thing being, it is very much possible for me to see this, and you have noticed this hole is in the other direction. Now, all I need to do is I need to take this and rotate it in this. They look a little like similar, except one of them is a through hole, the other is not a through hole, other is a blocked hole. So, using this it is possible for me now to wait, let me it did not get welded there properly. Yep, exactly. No waste of material. no waste of material. See here, I have a little problem here. Because of this, I will end up with a peculiar support required here, while this is through it is able to build here end up with a support problem. As I need to undo it, keep it back and rotate it in the other direction. Good, perfect textbook example. So, if you see here, building this is easy, it will continue to build like this, and now if you see this also, while outside it looks like this, the hole is at the bottom. So, the circular layers will be continued to be built. This is where I was telling you, you do not need to actually have a even 3D printing machine. Now, you can try your best to what you call create the layers. I will just quickly try to create just one or two of them and then see. I have got a, as before, a textbook example. I can slice each of these things, see how the build up is done, and it is a routine thing. So, instead of my talking, I will quickly try to do as best I can do. So, as before, I need to go for these what do you call split objects to be split, this one and this one. Cutting objects, all of them have been split. Total have been made into large number of 39 pieces, and like before, again there is a peculiarity of this particular machine, this solid, all the planar openings needs to be created. Now, if you see here, this is the topmost layer. Seen what it is, there is some issue with the cutting, but however, this is how object will start getting built like this. There was a problem in that cutting and this thing and so on, but the thing is saying what I wanted to what do you call actually tell you is that it is very much possible for us to check the orientation of the object and see how putting it in one particular direction it is obvious here, is it not? So, this starts building without any support is required, and the top layer it may need a support. So, you need to take a call once again, because it is circular, there is nothing, only that middle layer we may require something. So, you now decide where to cut it and how to make join things. Alternatively, in keeping in principle with the other thing what we are doing, if the hole actually intersects the other, you understand, no? So, I will go back here, it looks like there is a problem of some sort. So, I have this cylinder here. So, it is possible for me, I can continue to make it into a through hole this direction also. Now, cutting such an object will be easy, and see here I have a relatively neat object which comes like this, except that you will notice here there is a small opening here. It really functionally does not matter for me, or I can build things around. Now, when I cut the thing here carefully, it is possible for me to make it such that it builds perfectly well. So, I have the ready made object actually with me. So, I will try to show you the object how the original is, and eventually after it is all made, both of them have been joined together. So, I will have a look at that object as soon as that is over. So, I will stop here. You can see the object when I bring it, it is being fired as an end. In our case actually one was a screw insert, a metal insert has been placed here, other is a actually open hole. In this case screw insert was here, so that it will go and clamp something, and this one is something which is there. It was attached to a quadcopter at the base. In the quadcopter there is a rail, H rail which comes down. So, to attach some experimental load, 4 of these have been pushed onto that, then there is a payload has been attached and the whole thing has been used. So, thank you. I will continue after this sample as soon as the sample comes. Let me continue. I did a little bit of homework on that object which I had started yesterday, and I think this is it. You see, I have a very tiny practically invisible fastener in my hand. I do not know how to show it. Okay, it's really, this is a 2.5 millimeters clinch nut. Anyway, I have got a picture in that. Okay, one part of it is a hexagon, another part of it is a what you call threaded portion, and I will put it under, actually probably I need to have a 10x magnifier called a loop. I will put it on the loop and show it to you later. This is the small object. Why I am showing it to you is, kindly if you see here, we have a small issue when it comes to making threaded bores. Okay. So, here is one of those classical objects. So, you see here that if I now try to, I think it is clear, you can even make out what it is, except the dimensions, right now I have made it dimensionless. On one side we have an opening, and one side we have this, and then if I now make it by going to the properties, make it transparent, and then I give a rendering, you see the object that I have there. I hope it is a little clearer now. What we have there in fact is it is just a what you call just for the purposes of illustration. I have created a solid in which there is a provision for putting a threaded insert. In all other places, say if it were aluminum, we try to, if it is very small, we put a riveting nut or something. It is a sheet metal, on one side we have a riveted nut, or if it is a casting, we use something called a helicoil insert. I will just see if the internet is still working on the other monitor. You see, in the case of aluminum, it does not hold threads well, and even though you can tap it once, most aluminum, most alloys and all have a tendency to lose the threads after a little while. So, what is done is something called a helicoil is inserted into it. You have seen this? It is called a helicoil. It is nothing, it is a coil which it comes with its own tool, which there is a tap set, you tap it to the next oversize, then you insert one of these things. Well, it works well. We have still a little problem when it comes to, can we use it in plastic? Seen this, no? This is typically the way this helicoil stuff works. So, you have a hole, then you have a special what you call this thing here, then you have a device which inserts the proper installation and so on. So, this is standard practice when it comes to making this things in this. There is a good view about it here. Of course, often it is used more as a, how to tell, as a repair, but the reality is more than repair, it makes sense when we actually insert it like this. You see this? Now, attempts have been made to see whether we can extend this to plastic parts, and what I can say is no, it is maybe some plastics can take it, it is not ready. Plus, you can always put a metal insert and mold it around in the plastic. If you remember the very first two samples, I had shown you a box in which I will see if it is still there. It is still there. You see here, this is the type of an insert I am talking about. But then you see, this is our early stages, it is all crude, and finally this insert did not actually sit well. So, it did not serve our purpose. This must have been around 3 or 4 years old, I think 20, in fact 4 years old. Various attempts have been made to see if we can improve these things, whether this type of inserts and all can be improved on it. These are early these things. So, we have taken these proportions from injection molded parts, both plastic as well as non-ferrous alloy castings. So, the details do not look nice. In contrast, if you now kindly look at this monitor, back at the monitor, you will see that what we have done here is not the best. So, various ranges of these helicoils and bushes, these are freely available for metallic objects. Now, when you want to use molded nut inserts for plastic, see here we have so many of these devices which are available here. Can you see something here about this? It looks a little like a gear wheel actually. Essential things what you need to notice is that a type of knurling like object has been created here. It is not actually a cross knurling, but then the advantage being about any of these things are it does not easily come out of the, it does not easily get ejected out of the what do you call the part. These are the most common thing which are used in normal injection molded plastic. You see that one had that knurling, but it looks like a herringbone gear. This one has straight knurling and it has a small step inside. So, maybe it is patent, maybe it is there, and then you see here this could be a very common thing which even you can make, that is take any long hexagonal tube or I mean sorry not this thing, they are all usually available up to 50 to 60 long, and then part it and then afterward cut a groove, you have an object that can be easily used in injection molding. But now can we use that in our rapid prototyping? We have a little problem there. Problem there meaning how do we lay it up finally? Laying up is not easy, is it not? You have so many, in fact you have so many of these options, it is not at all easy. In fact everything you want self locking anything you want is probably already available there. See this, all the proportions are given, dimensions are given, all the various items. This is the one that I have picked and show you. Seen this, the one with the hexagonal thing. This one has coarse knurling on it. You have seen this? It's very tiny. Inside the thread could be, I mean the smallest thread will be around 2 millimeters. Even I have seen 1.6 and 1.5. Then you have going all the way up to about 4 to 5 Can we use it in our rapid prototyping? No, because we still have an issue of as we build layers, in case we put this insert there, it will get into the way from the nozzle, and if you try to push the nozzle, I mean push the insert after it is made, chances are it will not go well. So, it does not sit well because the material is not a free flowing material like either fully molded plastic, especially glass filled nylon or aluminum. So, we have to look into some workarounds. So, kindly if you see my that working computer, you see here what we have done. What has been done here is the object has been I will not save it, problem. What has been done is we have created a structure which will help us very easily in creating a what do you call one object in which we push that nutsert. Nutsert part of it has a hexagonal projection, after that there is a straight bore, and then this is where the screw goes inside. The advantage being when you try to build it in this form, if you try to build it like this, any way is possible. You can for example build like this because bottommost layer will be what do you call, it will be flat. You have seen this will be the bottommost layer, it will be flat, and as it goes up it keeps building everything, and finally that last layer will be a simple hexagonal layer where it is easy, it is obvious. In fact I can cut it and show you, but right now I think let us leave it there. You have seen this, no? This is the bottommost layer, then the layers will build up here, finally you have the hexagonal layer. After the whole thing is built up, now we take this small tiny hexagonal insert and push it from the top, and for safety's sake probably even put a little bit of super glue on this all around. And why is it so tiny? Because it is a 2.5 millimeter insert. 2.5 millimeter, it is very small. So, after the whole thing is made, instead of going about it, you will just find one small hexagonal opening, you just push it into the hexagonal opening and things sit neatly well. And for the purposes of our manufacturing, you see here we can make something neatly sit here, and the top layer can be covered with a vinyl or a sticker which can be contain the graphics which is required for it. So, any equipment invariably will have a few controls, then few displays. The control does something to the display, and then several terminations and several cautionary notes, and all of them can be made onto a vinyl sticker, and after inserting it into the what I call that base, after putting, just for safety's sake, you put a little bit of super glue, and then you can stick another layer on it. I am a little finicky and what do you call fastidious person. So, what we insist is we also take usually a strong polycarbonate sheet which is probably around 1 mm, coat it with some adhesive. In our case we generally use chloroform because I mean we have access to it, that we have set safety precautions. Then after that a full sheet is stuck on it after putting the inserts in it. Once you put the insert and put a full sheet on top of it and you allow it to harden or anything, it is practically safe, especially by mistake if somebody pushes it in this direction, if something is pushed in this direction, pushed it in the direction, that insert will come away. But this is exactly how the insert is used generally. So, it can be, for example, this whole thing can be built on a transparent this thing, or we add a LED window onto it where displays and all can be done. So, it is nice. All I can say is an extremely beautiful and convenient this thing. I will just to show, I mean while it is a little gimmicky, kindly put up with me. I will just try to make see here I have a nice convenient object. Since it catches the highlights, you know what the object is going to look like, and small just kindly bear with me for a while. If I delete all these faces, I have a wireframe like thing which in general shows you how the object is going to look. Seen this, no? They are the edges of it, and inside we have that small depression which approximates to the nutsert that I am going to push inside, or the clinch nut which I am going to push inside. And after putting the clinch nut, I will have a surface which is again as said 0.8 or 1 mm polycarbonate, which is generally hard, and depending on whether we have a what you call one adhesive which melts and sticks to that. Now, we have a beautiful object which is very functional, plus I can play around, make it into any shape I like, and it is a build, and we can clean it. I just wanted, as part of the fastening mechanism, I wanted to show you this. This is the object which I was trying to create yesterday. If you see this object, one of the thing it is, it has bores which is orthogonal to each other, and just for convenience I have put it in the axis intersect, otherwise there is no necessity for the axis to intersect also. Oh, this is only for the, in the case of illustration, unless you have this radius, the highlights are not caught. Unless you have the highlights, you cannot give a proper thing, but these are not convenient to build as such, but because generally you try to avoid all the fillets and build a beautiful thing which otherwise is not possible. Now let us say we need to build this in our normal 3D printing machine. So if you are to make it such that this wire, this line, I mean the axis of this circular thing, circular feature, a cylindrical feature is normal to the surface, meaning it is kept parallel, building here will be easy, absolutely no problem at all. If it were a full solid, this is probably the easiest way to build. Now comes the thing, other side I have a bore there, which I have shown you. If you remember here, if you kindly remember the previous thing, you see here I have a bore here. Now if I keep it flat and try to build as the software checks first, and then a little bit of a build material or support material is built here. Same thing here, here support material is accumulated. So I have rotated it 90 degrees along this this axis, and you see what will happen. Now the proper way is probably to build it in this direction. Looks okay, no? But again we have a problem. While we have solved the problem with the bottom bore, this filling up is required. So is there a way of getting over it? So what has been suggested is you cut it into two parts. This is what I was trying to tell you yesterday, or I will say previous session, I won't say yesterday. Now you see here I have made a hat section like thing such that I now split the object into two parts. After splitting it, this part can be made to build with this face down. This part will be made to build with this face down. So we have no necessity for any build material to be coming inside. So if you see here, it has been cut in this place and we have this like this. Easy, is it not? So I had made a small error which I will correct it towards the end. Now it is very easy after having split it into two parts. And why do I need this very funny thing? We need it because alignment is critical. Sometimes there is some alignment, especially the outer surface, is critical. So you see from both directions you can see it. This is the easiest way to build the object. Can you see here? Underneath there is a bore and there is something here. This is the, while it looks convenient, actually on further examination I had found out that this bore should have been through, then only it makes sense. Now building this, the layers will build up automatically, building here also will build, but to support this topmost structure again there will be a support thing required like this. So what to do? This has been added here. Can you see here a small cut has been given, and this has been added here so that it won't slide off. So now going back to the, say it sits, one sits over the other like this. It looks a little like a washing machine, isn't it? Unless you get into this level of detail, it is difficult for job to be successfully integrated. Now you see here, if you see carefully, I have this bore, logically this bore should have come out of here because functionally it will not make any difference. Now for location, left and right this is located, front and back if I push it, it is located. And depending on the type of material, either I can use super glue or I can use any of the solvents. So often chloroform works best in this. So with this now very conveniently I have objects which are created and which I was looking for. Now if you see at the bottom, it looks like this step, and then you see this here, We started here. Now, let me go back. See here, this is the object which I was trying to build actually. See in this? I started here. Can you see now? The small mistake I had done was in trying to cut it at a wrong point. So, all it would have been required was for me to what do you call just cut this. I will show you here, which I wanted to do, but I am not able to open both at the same time. See here, the bore should have been through like what is shown here. For the purposes of convenience, I have hidden all the faces so that you can see the object what it is. Now, if I make the bore through this and also make the steps, building it will be very easy. The easiest object probably one of the easiest objects that I can build would have been this. So, I just wanted to show you this as a what do you call way of whenever there are bores which are in the opposite directions or orthogonal directions, you need to split the object into parts, and when splitting also location is very critical. So, I have a nice very convenient thing here, and I will say it works extremely well. I think that is sufficient. Now, what you will notice in this particular case is that several issues are there. First of all, again I was telling you about how to make the build layers. To make build layers, you have to take the object and try to slice it. If you have any what you call 3D modeling software, typically Solid Edge, SolidWorks and so many on the thing, or in this case we have been using McNeil's Rhino trial version, and we have a student license on that. Based on that we have been using it, and thing is you need to think ahead to see if the object has been built properly. So, while it is at this point it is correct, now what will happen in case there is one more what you call opening which comes in the other direction. I have one here, two I have managed. Now, imagine I have one more which is coming in this direction, what to do now. So, if the job permits, it is always possible for us to break it up into small parts, alternatively put up with it. You have no choice, just put up with it. So, when you put up with it, you lose a little bit of the both the support material and build material, but however, in principle it is possible to do it. There the rule being, actually why I have made this is, if the diameter to length is the issue, typically flat circular annular ring like things are, there is no problem about the material. So, you have a neat ring, imagine you have this like a bangle or any of these things, when it is round, if you make it flat you can build it, and even if you are to make it here, little bit of this material built up you can push it out.